Hi, in this next video from section 1.1, we're going to do some more where we use linear equations to solve real-life problems. The circle graph shows percents of different animals sold at a local pet store in 1 year. What percent is represented by the entire circle? This is supposed to just be prior knowledge where you know that a circle graph always represents 100%. How does the equation 7 plus 9 plus 5 plus 48 plus x equal 100 relate to the circle graph? Well, 7 plus 9 plus 5 plus 48 plus x makes up the entire circle. All right. From there, we could set it up to equal 100% and then solve. So what I'm going to do is take 7 plus 9 is 16, plus 5 is 21, plus 48 is 69. So now we have 69 plus x equals 100. If we do the inverse operation on both sides, we'll get x equals 31. And that is what we have for percent of cats sold. Right? So we should probably label it 31%. 1/6 of girls and 2/7 of boys are in a school marching band, are in a percussion section. A percussion section has 6 girls and 10 boys. How many students are in the marching band? So we don't know how many students, so let's set a variable here for 51 and say x equals marching band total. From there, we'll say 1/6 of x for the girls has to equal, so 1/6 has to equal 6 girls. And then we can also say 2/7 of x equals 10 boys. All right. From there, if we divide, so that's 1/6 times x, so divide off by 1/6, or you could also times by 6, 6 times 6, and we get x equals 36 girls. Here, if we divide by 2/7, divide by 2/7, or you can multiply by 7/2, multiply by the reciprocal. You should get x equals 35 boys. So how many students are in a marching band? From there, we should be able to say 71 total, because we would add 36 plus 35. All right, on to the next. Okay, this is again trying to use simple equations that pulls on prior knowledge to find the volume of something, and it gets more specific if you want to go into individual shapes, but at the very base, it's volume equals base times height. We're pulling on that formula. So when it says find the height or the area of the base of the solid, all we're looking to do in 53 is something where we go 7 the height times the base, this b represents the area of the base, equals 84 pi. From there, if we divide both sides by 7, the area of the base is 12 pi. We want to keep the pi symbol now. If it's in terms of pi, we're going to keep it in terms of pi unless we have a reason to cancel it. On 54, if we want to take the area of the base, 147, times the height, h, equals 1323. From there, we'll do the inverse operation, so we'll divide both sides by 147, 1323 divided by 147, and we'll get h equals 9. 55 here. We'll take the base times the height. Now, let me back up just a little bit. So this is for what's known as prisms. Prisms have the same base on both sides. So they have matching bases, right? When we have pyramids or cones, things that come to a point, then our volume changes to 1/3 base times height. So now we want to do 1/3 and 55 because it comes to a point. Base times 5 equals 15 pi. So the first thing I'm going to do is take 5 times 1/3 and make it 5/3 base equals 15 pi. Just to clean it up a little bit. Divide by 5/3, divide by 5/3, and get base is 9 pi. Again, there's nothing to cancel out the pi there. Okay, and then to finish up on this one with 56, we'll have volume equals, so 1/3 base times height equals 35. 1/3 times 30 is 10h. Divide both sides by 10. And we say h equals 3.5. All of these should probably be labeled. So this one should be inches. This one should be centimeters. Actually, base should be inches squared. Height is just a straight measurement. This should be meters squared. And this one should be feet. In a baseball player's batting average is calculated by dividing the number of hits by the number of at-bats. The table shows player A's batting average and the number of at-bats in 3 regular season games. So a player's hits divided by at-bats equals average. That came straight from this information. How many hits did player A have in 2011 regular season? So we don't know the hits. We know the at-bats was 446 for an average of 296. To undo both sides, that's a divide by 46. So we times by 446, times by 446, and we get x equals we get roughly 132.016. This seems really goofy, but just trust me on this. We're going to round this up to 133 hits because this average was probably rounded, and the only way we guarantee that we get to that average round is to take the number of hits up. Player B had 33 fewer hits in the 2011 season, but had a greater batting average. Your friend concludes that player B had more at-bats in 2011 than player A. Is your friend correct? 33 fewer hits. So if we do player B's number of hits, we'll take 133 minus 33 and get 100. So 100 hits. And it said that this had to be greater than player A's batting average, right? So 33 fewer hits. So we had 100 hits. We don't know how many at bats using this up here. And we're going to say that we're just going to set equal to 296, knowing that we want it to be bigger than. And a weird thing here, we're not actually going to mess with the number first. It's hard. So we're going to multiply both sides by x and turn it into this problem. Then we're going to divide both sides by 0.296. And we should get something like x equals, to just have the exact same batting average as player A, we'd round up to 338. Just to have the exact same batting average as player A with 100 hits, it would have taken 338 at bats. which means player B didn't have more at bats, because the more at bats he had, it would have went down. So actually, no, false, incorrect, something like that. All right. I'm going to come back to you for this last slide.